right, guys, the other one for our little mini unit here. We're going to talk about inverse functions. So again, dealing with functions, but what does their inverse or their opposite function look like? Which we've talked about this briefly in class, like a couple of times we've hinted at it here and there. So hopefully this will kind of bring that all together. So we'll do that on 83, 84. This line here is just a goof. We'll do a little mini quiz after this, and then we'll move on. So turning to 83 and 84. Oops, I didn't number my last ones. Let's go 81, 82, and then we got 83 and 84. Okay, so we should have two things here. Kind of this backwards book, which we'll put on 84. Then we also have a magic book, which can go on 83. That's for some extra examples here, which I think are also very good. With our magic book, we will have to cover up example 4, but that's okay. Okay, so it's super important that we do the lab that is attached to this. The lab is very helpful. But essentially what an inverse is, so if we're thinking about the graph, the equation, or a table, we might think about this in different ways. So one way to think about this is if the graph of our function passes both the vertical and horizontal line test, then its inverse is also a function. And if both of those things are true, then we're said to be 1-to-1, which is really nice because either way, if I have the function itself or its inverse function, both are functions, and that's really, really good because functions are important. We don't like non-functions. Okay, so if I'm dealing with an equation, so these are going to be our equations. There's kind of one of two ways we can really go about finding its inverse. Okay, so how to write an equation's inverse. One thing that you could do, and this is sort of the straightforward way, is swap x and y and solve for y. So like if you just like straight up algebra and you are a very straightforward person, this is probably the way to go for you. So I'm going to do the first one like that. Okay, so if I look at example 1 right here, I would want to swap where x and y are. So this is going to be x over here now. This will be y. And then I need to solve for y, so get y all by itself. So over here now where y is, there's lots of things happening to it. I need to first get rid of addition and subtraction. So I'll have x plus 2 equals 3y squared. Then I need to get rid of multiplication or division, so I need to divide that 3 by all the things. And so we have this mess here. Oh my gosh, I might have to squeeze this in. So we have, I'll just rewrite it over here. X plus 2 divided by 3 equals our y squared. And then the last thing I have to do to get y all by itself is square root. And so my final answer, sorry, moving back and forth here, y all by itself is equal to the square root of x plus 2 all over 3. Which, if I think about these two functions, this one is a parabola, this one is a hook. And both those things are functions. Kinda. Because like this one actually does not pass the horizontal line test. So technically this one is not. If I only consider the top half of it, this is kind of the positive square root. If I consider the bottom half of it, the negative part of the square root, then it's not a function, but it depends on how we think about it. But there you go, that's how you find your inverse. Now the other way to do it, so this is kind of the pink example. The other way to do it is more of a thinking about it. So those of us who don't necessarily like to follow steps and solve like step by step by step, another way to do is think about what the function's doing. And how do I undo that? Okay. So think about what the function is doing, and then how do I undo that? So this is a very like thinky thing. I'm going to kind of try this on this one. So for example, x right here, if I knew how much it was, the first thing I would do is subtract 1. Then I would cube root. Then I would kind of multiply by a -1. And then I would add a +2. Now I need to fully flip that, like totally on its head, and do the reverse. So this is the way I went. Now we're going to reverse it. So this is the way I'm going to go now. I'm going to do -2. I'm going to divide by -1. I'm going to cube, and then I'm going to add 1. And so if I take x through my line of things here, so I'm going to do x -2 times by -1, so change both the signs, cube that, and then add 1. You get your inverse function. So this is inverse. I should have put a little -1 here. Boop. That's how we show it's the inverse. So kind of wild. Kind of wild. And again, you can just follow the steps. That's much easier. But some of us just like to think about the things, and that works for us. So that's good too. Kind of write out our chain of events, and then we undo the chain of events. Another thing to consider is instead of looking at the equation, when we are looking at the graph of a function and its inverse, okay? So if we're going to think about graphing it, again, kind of one of two ways. First way is just like graph them straight up. So graph your function and your inverse function based on what you know about their shape. Now this one requires that I find both. Okay, so again, I'm going to do an example of each. So like if I do this first one here, right now I only know the function itself, so I kind of have to find the inverse. So I could swap my x and y. And then actually I'm going to do the thinking about it because that's kind of faster. So if I know x, I'm going to add 3 and then divide by 3. So if I just undo that, I take x and I multiply by 3 and I subtract 3. Okay. And so then I have to graph both of these. So this first one is a line with a slope of 1/3 and a y-intercept of 1. So we go to 1, we do a slope of up 1/3, and we get this line here. The other one is also a linear equation, so this is my inverse function with a y-intercept of -3 and a slope of +3. So we go up 1, 2, 3 over 1, 1, 2, 3 over 1. So again, very straightforward. We follow the steps of both and we just graph them both. Maybe the less straightforward way is we could, oh, I guess there's maybe a third way to do this, I guess. The second way though that I like to do is graph the function, then reflect it over the line y equals x, because that's what will always happen. And then kind of the third way, which is maybe my least favorite way, and so I'm not going to do it, is make a table for your function and then swap x and y for the inverse function and then go graph that. I mean, that's kind of what you're doing here a little bit, because if you think about it, this point here was at -3, 0. So if I flip that, 0, -3 goes here. This was at 0, 1, 1, 0. And then this was at 3, 2. So then I go 2, 3. So I kind of did it here a little bit, sort of the last one. But then this other one I kind of like. So graph my function and then reflect it over y equals x. Now this one right here is truly just the square root of x. So that starts at 0, 0 and has a slope of 1 and looks like the hook. And so then if I think about drawing in this line of reflection, so the y equals x line goes straight through the middle here. We just want to reflect everything over that, which actually, that's kind of annoying. Both these points are on it. But the other point that I can plug in pretty easily here is 4. 1, 2, 3, 4, because that's 2. And so if I take this and I reflect it over the line, then it goes here. And so I can see that this is actually going like this. Which, whenever I'm reflecting, I always like to turn it straight so that it looks like a mirror to me. So yeah. Yeah, I don't know. Either way, kind of both good. I should have done that in blue. Oopsies. Because that's that one. Okay, last thing, and then we'll try some more examples, is sometimes I have to verify the inverse. So when I'm verifying something, they're giving me the problem and the answer, and we're trying to see if they match up. So are they inverses or not? And how do we check? So again, they're going to give me the function and its inverse, or its potential inverse. The way I check is we do function composition. So either f composed with its inverse or the inverse composed with f. Either way is fine. So we're like plugging one into the other, and then what we're hoping for is to just get x at the end. Like if you think about that, right, whatever I do to the function, the inverse undoes. So if I do everything to it and then I undo all the things, the only thing I should be left with is what I started with. So the only thing I should be left with is my input, which is x. So, for example, if I take number 5, if I have these two where they're potential inverses of each other, I can put one into the other or the other into one. Like it doesn't matter. So I'll just take the top one here, 2 minus x. But like instead of x, I'm going to put this function. So square root x plus 2 squared. And the moment I look at that, I'm like, I don't want to do that. I would have to write this twice and FOIL it. It wouldn't be terrible, but I wonder if I plug it in the other way, if maybe it doesn't work better. So maybe I start with this one instead. So the square root, because I can choose, I can do either. So we're going to do square root of x plus 2, but instead of x, we're going to put the function 2 minus x squared. I don't know if that's any better, truly. I feel like that's worse. Because, like, I don't know how to get rid of the squared. And I'm going to have to FOIL down here anyways. Oh, that's not worse, because I'm just going to FOIL this. That's fine. We'll do that. Okay, let's FOIL this. So we have this one here. There's, like, not enough room. Got the big old square root. We're going to have 2 minus x times 2 minus x plus 2. So if I FOIL fast, we're going to have 4 minus 2x minus 2x to minus 4x plus x squared plus 2. Maybe this is awful. Maybe this is awful. I don't know. We'll keep going. So then we have, 4, 5, 6 minus 4x plus x squared I mean, I could try to factor that. What multiplies to 6 and adds to negative 4? I don't think that factors. So this seems like it's not going to simplify anymore. I think they're not inverses. Not inverses. However, I should have done one that wasn't inverse first, maybe. On this one, I think we will be. So we'll start here and here. And let's just start with this 3x plus 4. Except instead of x, I'm going to put in what it equals. So x minus 4 over 3. And so now if I simplify this, the 3's will divide out. And so we'll have x minus 4 plus 4, which negative 4 plus 4 is just x. And so I did end with x. So they are inverses. Yes. Inverse. Yay. I'm going to skip that bottom one. Let's jump over to our magical book here and try some of these. So looking at this first one, this is kind of the ordered pair thing or the table swap thing that I was talking about. So if x comma y is on our function, then we can just swap y comma x. That would be on our inverse function. So looking at the table here, comparing the function to the inverse function, we can see that x and y just swapped. So like this got to be negative 3. I just have to assume that these go together. So like this should have been the 1 and that should have been the negative 15. The 17 and 5 probably went together. So 17 and 5. And then this has got to be the 33. So we're just swapping. We have our function and our inverse function. So 0, 10 or 10, 0. 1, 1 and 1, 1. Like it swapped. You just didn't see it. We had 2, negative 2, and then negative 2, 2. I don't know if I can know that one. So 4 comma 10 and then 10 comma 4. Maybe this is following a pattern. 0, 1, 2, 3. Oh, probably a 3 here. This went down by 9, but then that did something weird. Oh, I think it's like symmetrical. That kind of looks right. So then maybe this was a 1. So then 1 and 3. That makes sense. Cute. Little deduction. The other way to think about it, the way that I kind of like, is that our graphs are reflected over the line y equals x. So if I sketch in that reflection line, I can just like flip these points over. Now again, like for reflecting, for me, it's kind of tricky. Like I kind of need to see this. But I mean, also I just know the rule. Like reflecting is going to mean change the ordered pair like we were just doing. So this one's at negative 1, 1. So it's going to go to 1, negative 1. Like it flips over here. This one is at negative 2, 3. So we're going to go to 3. What did I just say? Negative 2, 3. So 3, negative 2. And then this last point here is at 1 comma negative 3. So a negative 3 comma 1. Let me get this line. Oop, I missed it. But yeah, that looks right. Totally reflected. It would have been better if I went through there. Anyways, last one to try like this. We get our reflection line. You could also use trace paper, which is great. Like trace this here and then just like flip it over. But like I can kind of see this one. It's got to go here. And then this one's kind of like 1.5 squares away. So gonna go there. And then this is like 1 square away, so there. And again, like if I turn my paper, I can kind of see better how I need to sketch this. Kind of does like a vase thing. Cute. Cute, cute. Think of a mirror. And then last but not least, we want to find our inverses. So one way we can do it is we can think about what's happening. So if I was x, I would first cube, then take half, then add 4. So if I flip it, switch it, and reverse it, I'll subtract 4. technically I divide by half, but like we multiply by the reciprocal, so 2, and then I cube root. So if I take x through this, we're going to go x minus 4 times 2 cube rooted is my inverse function. So that's one fun way to do it. The other way to do it is to swap our x and y. So right now this is y, we're going to call it x instead. And then we just solve for y, like get y by itself. So I'd have to square both sides. Add 4. So x squared plus 4 equals 6y. And then divide by 6. And so my inverse function is x squared plus 4 all divided by 6. And again, if you think about it, if I was x, the first thing I would do is divide by 6, and then add 4, and then square. It's like we get it. It's getting there. Okay, last but not least, this one here, I'm going to do the thinking about it. So first thing I would do is square, then subtract 4. So if I undo, flip it and reverse it, we're going to add 4, and then square root. We'd have x plus 4 square rooted. Inverse function. Again, if you think about it, it's the exact opposite. Like instead of squaring, I'm square rooting. Instead of subtracting, I'm adding. So cute. Oh, I'm supposed to determine if it's 1 to 1. Yeah, whatever. That's fine. See you on the next one.